record. And write this down. All right. So one problem from 1C. And this is use Venn diagrams. 2. This is looking at deductive arguments, and it is 1D. 3 is out of 2A, and it is just simply working on steps, looking at how to solve problems, understand, solve, explain. 4 is from 2B, and it is converting units. 5 is from 3A. Finding a percentage change. Number 6 is from 3C. It's looking at significant digits. Number 7 is also from 3C. Also working with significant digits. Number 8 dealing with CPI, Consumer Price Index, or price index, calculating inflation. Just looking at if something cost this much in 1990, how much would it cost in, say, 2020? So number 8. Oh, wait a minute. Let me see. Yeah. So number 8 was the price index problem. So that's 3D. Number 9, it's a little out of order, but it's working with scientific notation. And that's actually out of 3B. So you note there was a skip here from 3A. So it is 3B. Number 10. And it is out of 4A. And that is, we were in 4A looking at budgeting. And it's calculating a cash flow, which means basically with that when budget, how much money are you bringing in? How much do you have going out? And the difference is your cash flow. And you would hope that's positive. Then number 11 is out of 4B. And it is looking at interest, compound interest type problem. Number 12. Now we get into statistics, and it's out of 5A. And it's looking at sampling. So 13, also looking at sampling. Number 14, and I guess I apologize. I said, well, shoot. Yeah, okay. It is 16, not 15. So 14 is just looking at is data qualitative or quantitative? And that is 5C. 15, looking at central tendency, mean, median, and mode. It's out of 6A. And 16, you're looking at constructing a box plot, and that's out of 6B. Now, again, I'm looking at 17, and I'm just not sure here. I'm going to say 2 to 3 problems here. At most, so, or 2 to 4. I'll just give myself a 2 to 4 range. And these problems I will pull right from the homework out of 2A or out of 7A on probability. But they will be straight out of that homework that I assigned. There was 15 problems, 1 through 15. So you're looking at, in this case, looks like a total of 18 to 20 problems on this test. Okay, so that's just an overview. So basically, you're looking at essentially a problem for almost, except for 5A, a problem from each section that we had covered this semester. So let me do this real quick. All right. All right. So oh, okay. All right. So are there any homework questions from anywhere in the semester? Anything you've been working on, you're trying to catch up on, that we could go over right now?
I just had a question. Are you gonna have class like anytime next week or no?
No.
Okay.
So finals week, their classes do not meet other than taking a final.
Okay.
And we've already established that you're going to, this final, you'll just take virtually, like you have your other exams. Just you want to be sure, since I'm going to set it to take twice, don't wait till right up to the deadline, early Saturday morning.
Okay.
But sometime next week. But now that said, if you have questions about problems or need help with anything, shoot me an email.
Okay.
I will not be on campus Monday, and I probably will not be on campus on Tuesday. Though I may, in the late afternoon. But I definitely will be available to be on campus Wednesday, Thursday, or Friday of next week. So if you want to go over problems, if you're on campus, but I can always set up a Zoom session.
Okay.
And so shoot me an email and we can do that as, either Zoom session or on campus next week. But I will definitely make time for you if you need any help at all.
Okay. I appreciate it.
So so let me see if I can. Let me do this. And it'll be worth it if I can find them. Just in terms of, since it's only right now 16 problems. Seven, 7, 2, 3, 3, 2, 1. All right, so what I want to attempt to do is, let's see. Okay, so what I'm doing is kind of narrowing your focus a little bit if you're looking to study. Now, what I'm basically going to do is give you a homework problem out of each of these sections. That is that I just wrote down here. It's not going to be exactly the same problem, but it's going to be very similar. So I've just done the first two. I just have to do some cross-referencing. So I just put the section number from each section that the test problem is pulled from. Then here, I'm just going to put it in circling it. So on 1C, go back to the homework on 1C, you can look at number 13. Again, it's not identical, but it is same concept. So that helps your focus a little bit. And we can go through these here if you want tonight, some of these, but at least that will give you an idea of what to look at in terms of studying. So 1D is number 12 would be the problem out of homework section 1D. All right, so 2A. Number 1. Look at number 1. All right, 2B. All right, looks like about number 5. And these are just the similar problems. 3A. 3A. Looks like this one, I'm gonna give you two problems. 14 or 15. Section. All right. Three B. Oh, shoot. Okay. Now I know why I did that. So this one right here, I will eliminate. I'm not, well, no, hold on a second. What's going on? Get, huh. Let me go check something real quick. Yeah. Okay. That's what I thought. So, and this is one of those, my math lab had a mind of its own. For some reason, that is showing up not assigned, but it was assigned. So if you try to get back into 3B, you would have had a issue. I just fixed it. It is now back assigned. All right. Now let's go check the 3. So get rid of that. And looks like number for 3B, number 6. This was scientific notation. So off the homework there. All right, 3C. It's like this one. So these are both significant digits. They're kind of interchangeable. Look at 21 and 25 of 3C homework. And 3D. Number 9. Once we've done that one, all right, 4A. Number 14. For B. So number 17. All right. 5A. Okay. So. It's not showing up. Give me a second. All right, looks like number 16. It's a comparable problem for the problems out of 5A. So so on the homework, number 16 of 5A is what you want to look at. 6A. Six A. All right, so I guess I skipped over 5C. 6A. It's like about 19. Again, this is just a similar problem with concepts, not exactly the same problem. 6B. Number 13. And 5C. Oh, this. All right. Let's just not write something down. Qualitative or quantitative. C. Number 12. All right. So that gives you a little bit of focus on your study. You can go back in the homework and look at those individual problems. Now, again, it's not identical. It's just similar and covering the same concepts. In addition, I'm going to pick 2 to 4 from that last homework section of 7A, probably just a couple problems. So I'm looking at probably 18, more than likely. Pick just 2 off of that last section. All right. So if that's it, are there any you want to look at that I've just pulled up? Any of the statistics? Or anything?
I did have a question on the homework that you did just assign because I looked at it.
Okay,
And on question 4,
okay,
so me and my mom worked on it, and it says the probability of having 2 girls and 3 boys in a
Okay.
5-child family, and we couldn't figure it out.
all right. Well, let me find the problem. Okay, 1 girl, 3 boys.
This one has 2 girls and 3 boys.
Is it number 4?
Yeah,
Okay, so that's how yours is written up, I guess, is the deal.
yeah.
Okay, so I gotta go find your problem. I gotta
Okay.
go to another place here. 7A. Number 4. Okay. So, so this is 7A, number 4. So your problem said determine the probability of having 2 girls and 3 boys. 5 spell 5-child family. All right, so basically, if you have 5 children, what is the probability that you're going to have 2 girls and 3 boys? So remember what we're going to have to figure out. We're going to have to figure out basically every possible outcome of having 5 children. I mean, you could have 1 girl and 4 boys. You could have 5 boys. You could have 5 girls. I mean, so how many different possibilities are there? And then how many outcomes are the desired outcome that you're looking for, that desired, how many outcomes match up with the event of having 2 girls and 3 boys. All right, so let's do some calculation. Okay. So it's not. All right, give me 1 second. What I don't really want to do here is write out every single possibility, because I got a feeling there's going to be a whole bunch of them.
Yeah, that's what we did.
Yeah.
Yeah, we sat there and tried to figure it out, and
All right, so let's figure out a quicker way than writing them all. If you just have a couple, it's not as bad, but if one like this, yeah, it's gonna take a little while. So, okay.
what is it?
Ask him if you can go 2 to the 5th and making it 32 possibilities. That's my question. Can he hear me?
I
Can you
could.
go to the?
Can you
yeah,
hear, can you hear me?
I
We're
did.
trying to figure it out.
Well, because what we did, hi, I'm the mom, by the way.
Hi, Mom.
We've been sitting here, we've been working on this. And so what we were looking at is we were actually trying to do what you were doing, and we were trying to go boy, 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 girl, girl. Okay, so that
And-
got too much.
Yeah.
So-
Yeah,
Could you
that's,
take it 2 to the 5th to give it 32 possibilities
well,
for that to be the denominator?
right.
Because like, if you look at it, so like if you take 5B, so if you just say 5 boys to 0 girls, right? And then
Uh-huh.
4 boys to 1 girl, 3 boys to 2 girls. And so we kind of visualized it that way.
Mhm.
And so when we were looking at it, you're gonna have at least a boy and a girl, which would be 2 to a 5-member family, right?
Uh-huh.
So could you take that and get 2 times 2 times 2 times 2 times 2 to get 32 possibilities as a
Well,
denominator? To simplify that.
yeah, it, yeah, give me,
Sorry. I
no, no,
just-
no, no, don't apologize.
yeah.
Let's see here. Now,
It's like if you did.
since there are 5, it seems very reasonable that it would be, since there are 5 and there's 2 choices each for each slot, either boy or
Right.
girl.
Right.
So let's say that. Now,
Yeah.
here's the only other issue, and I think at the end of the day, we're going to probably have to write them all out anyway, because the second thing we have to figure out is how many outcomes are the desired event, which in this case is 2 girls and 3 boys. And what I mean by that is, if we think, okay, we have 5 children,
Mhm.
well, and even if you would have quintuplets, there's still an order at which they're born.
Right.
And so you could have, you could be first, second, third, fourth, fifth, are all girls, let's say.
Right.
Okay, so that's your first possibility. Then it could be the first child was a what? Boy, and the next 4 were girls. Then it could be boy, boy, girl, girl, girl. Oh, boy.
See, so if you, the way we did it, if you
Mhm.
put 5G, so just put in 5G,
Mm-hmm.
0 Bs.
Yeah, sure.
Okay, so
Well-
that was what we did. And then you go 4 girls and 1 boy. 3
Yeah.
girls and 2 boys. So if you look at it that way, it is so much easier, because we were doing that. Oh my God.
Well, we're right now looking at 32 possibilities.
Right.
And so,
So if you look at, so if you take those, and I'm just thinking out loud here, and I don't mean to be
no,
like
no,
interrupting your class or confusing any of your kids.
it's fine.
But if we did the 5, so if we did 5 girls and 0 boys, and then we did 5 boys and 0 girls, right? So this is how we did it. We took all the boys, 5 boys, 4 boys, 3 boys, 2 boys, 1 boy, 0 boy, right? So we
right.
did all of that. So that came up to 32. But then if you're looking at the probability of what the outcome could be, if you're looking at 3 boys and 2 girls, there were two of those.
Mhm.
If I'm looking at that correct,
Well,
you see what I mean? So I don't know how you look at that. Because you can
okay.
either have 2 girls and 3 boys. Well, that's what you would have, 2 girls and the 3 boys. So that would just be the 2 choices that you would have.
Okay. Huh.
I know, it's confusing when you have,
Um,
they don't need to
Well-
have that many kids.
Yeah. that's what I said.
Well, all right, so let me, let's do this. Um,
I want to say it's 1/16.
well,
That's all I want to say, because I want to say you can come out 232s and you resolve that down to 1/16. But I
so
don't know.
if you, let's try it this way. Let's list out all the outcomes possible with just that combination. That shouldn't be too awful many. So that is girl, boy, 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 I say girl. Could have went boy, girl, girl, boy, boy. Could have been girl, could have been
Like this.
girl, girl, boy, boy, boy. Could have been
Girl.
boy, girl, girl. All right. Could there be another possibility?
All girls. Right?
So it could be girl, girl. Nope, can't be that. Already did that.
So we already have 5. So then you would have 4 girls,
Could be. Girl, boy,
right?
boom,
Three
boom,
girls,
boom. Um,
boys. 2 girls. 3 boys,
Girl.
right?
boy,
1 girl,
girl,
4 boys,
boy.
and then 5 boys,
Now there is 6.
right?
Mhm.
All right. Here was 6. That's a 6 that I just came up with right there. Could do it in terms of order. If we assume on the left is first and on the right is last. Where every one of these, there's what, 2 girls and what, 3 boys. Is there another possibility beyond what I've just written down as far as these 6 go? Boy,
2 girls, 3 boys, right here, right?
girl, boy.
2 girls, 3 boys.
Yeah, here's another one. There's 7. And
Yes, have 2 girls and 3 boys.
Oh, I see.
girl. Boy. Boy. Girl. All right, so now I've up to 8. And could there be another one out of past 8? Hmm.
I can't think of any more.
$12. All right. Want to do one more thing. And I do apologize on this one. I didn't realize it was going to throw, like all the ones I'm looking at here
Mhm.
on assignment manager.
Mhm.
It's 3 children max, which that's fairly easy to write out all the possibilities. There's only 8.
Right.
This was something a little bit different.
I just
But-
don't want her to get it wrong and.
Right. Well, what I want to look at now. Shoot. I think I know the answer now. I think I've got it. How many times have you put the answer in there, Kylie?
I put it in 3 times. Well, I mean,
No,
2
should be
times.
Should have counted it. All right, you put it in twice. You haven't had your third. strike
Yeah,
yet. That's
yeah,
what
I'm
you've
on my
done.
final one right now.
Gotcha. Have you tried to put in 3/8?
No.
No.
Okay, don't yet, but I'm just.
Okay.
So I'm gonna try one other thing here. Aha. All right, now we're cooking.
We can probably answer this.
But at least I'll be able to. Okay. So, so I have listed out here so far, what, 8 possibilities, right? In terms of order.
Right.
And then I kind of stopped and I was trying something else. Can we figure out 2 more?
What do we have?
It has to have 2 girls and 3 boys.
Has to have 2, and so
We have 2 girls and 3 boys here. So.
I think there's 2 more. In fact, I know there's 2 more.
How about 2?
So,
Oh, no, I wouldn't do
um,
that. I would have 2 boys and 3 girls. But that,
Um,
boy, girl, boy, girl. All right, that's different than anything else I put up there. And
Yeah.
then did that, did that, did that.
girl, boy.
So
Can you do?
no. You have to have 2
Boy.
girls and 3.
Yeah, I know, but if you did boy, what about? Oh, never mind. Here I got it.
girl, boy.
Girl.
Nope, got that one.
Oh, yeah.
Mhm.
got to be one more. Uh,
Let's see. Girl, girl. Or you have to have 3 boys and 2 girls.
Oh, girl, boy, boy, girl,
Boy,
boy.
yeah.
Yeah, don't have that one. All right. That is 10. All right. And I think I've got them all. Now, we also said there had to be what? If we were actually took the time to write all of them down, there would be a total of what?
32.
32 different ways here that this could happen. Now, and that 32 total outcomes, we came up with 10 outcomes, which were the desired event, which is you have 2 girls and 3 boys.
Right.
So that would probability makes it 10 out of 32.
Mhm.
And then that fraction would reduce to what? 5 what? Uh 16ths. 2 would go in the top, 2 would go in the bottom.
5/16, yeah.
Yeah.
Okay. All right. Punch in 5/16.
I'm not sure if I can in here.
You can minimize that, can you? Yeah, there you go, come up here and then go to.
No.
Huh?
So that should be it. Did it work?
I'm putting it in real quick.
Oh, okay. That should take care of it.
There you go. I'll put in 5/16. There you go, 5/16.
Yes, that worked.
All right.
Uh,
All right. All right. So just as I said, as I was looking at here, the different possibilities with, when it changes up the problem using a random number generator, most of the time it was 3 kids. So it was much easier to calculate than with 5, though we've now seen what 5 would be. And if the problem came out 3 boys and 2 girls, the probability would still be the same.
okay.
It would still be 5/16. So I would hope that I haven't seen it where it gives like 6 children or 7 children. But I'm not going to risk it. I probably won't put this one on the test.
Okay. Thank you.
All right, well, you got it right now. So it actually wasn't figuring out the total number of outcomes. It was figuring out how many were the desired event. So,
Yeah.
all right. And I know we did that one in class. And so I'm just kind of moving on, looking at some of these other problems while we're in here. Just got to number 6. It's got local weather forecast has been accurate for 25 of the past 33 days based on this fact. What is the relative frequency probability? Remember, that was also called empirical, that the forecast for tomorrow will be accurate. So it was accurate for 25 of 33 days. And so if you just simply divide 25 by 33, it asks you to go to 3 decimal places. It says actually nearest thousandth. So exceedingly much easier than number 4. So again, this is number 6 I'm looking at. And so it'll change up the numbers when you look at it, but it says 25 of, for when I'm looking at, it says 25 of the past 33 days. And says give the answer as a decimal, round to 3 decimal places. So just 25 divided by 33, and that comes out to 0.758. 75.8% chance that the forecast tomorrow will be accurate. Okay. Now, moving on, just because number 7 says you toss a coin 100 times. I'm going to assume it's a fair coin, not weighted. You get 6 tails. All right. So what if you got 6 tails? What would be the relative frequency probability? And so just like number 6, if you flipped it 100 times, you got 6 tails. That's 6 out of 100, which as decimal is 0.06, 6%. Now, that's where you put in the relative frequency, what's called the relative frequency. So you calculate it. Now, the theoretical probability, what would you be the expected frequency of the event? Since it's a fair coin and you got what is, flip it once, you got 2 possibilities, total possibilities, 1 event, which would be tails. That's 1 out of 2, or 0.5. Then the third question is, do you have reason to suspect the coin is unfair? And you're going to say, yeah, definitely. If you flipped it 100 times and only got 6 tails, it's possible that could happen, but very unlikely. Since the frequency distribution probability was 0.06, but the expected was 0.5, that's 6% compared to 50%. So you're going to say, yeah, because the relative frequency is not close to the expected frequency. All right, on the last question. All right. Okay. Now, looking at number 8. 8 doesn't ask you to calculate a probability. 8 just asks what should you use the method. That is relative frequency, theoretical, and we also talked about subjective, which is just intuition, gut feeling. So the question is, what is the probability of being dealt a pair of 2s in a 5-card hand? So we're not actually calculating what that probability is, but should we go relative frequency? Should we go theoretical? or subjective. So we'll throw subjective out here. But I would say theoretical in that part, because what we can do is we can count out all the possibilities of coming up with hands that have a pair of twos. And it's just much like the five 2 boys and 3 girls problem. You got 5 cards. And we're saying, what is the out of that 5 card, you could be dealt a 2 on the first throw and a 2 on the last throw, and the 3 in between or something else. Now it's a lot of counting, but you could count it out. So we're not having to estimate, which is more what relative frequency is, because it's kind of like taking a sample. Here I could count out all the possibilities, so I could get exactly what the probability is. So you would say theoretical in that case on number 8. So let me throw this question out to you. This is number 10. What is the probability that a 59% free throw shooter, which is not very good, will miss the next free throw? What would you suspect? Now remember, if you've got the percentage, you've actually got the probability. That means if they are a 59% free throw shooter, the probability is they 59% they're going to make the free throw. So what would be the probability they miss the next free throw? And here's a hint. You have an event A and you know the probability, then the event not happening is equal to 1 minus the probability that it does happen. So if you've got 59% chance that it is going to happen, what is the percentage chance it's not going to happen? I'm sorry?
58.
No. So put it in here. So if I know the probability of making the free throw was 59%.
Mhm.
Okay, now as a decimal, that is 0.59. And so what would be 1 minus 0.59?
0.41.
That's it, 0.41. I think what you did there was you just took 1 away from
59.
8. Yeah. So you want to turn it, go ahead and turn it to, you can either go 100 minus 59 or 1 minus 0.59. So it'd be 0.41. do this one too. We did one like this on Tuesday, but it's worth doing it again. And number 12, this deals with odds. So let's say the odds against a bet, the odds on your bet are 9 to 8. Those are your odds. And you're going to bet $40 and you win. How much do you gain? So the odd means if you got 9 to 8, that for every $8 you bet, you win what? $9. So if you bet 40, then again, for every $8 you bet, you win 9. If you take 9/8 times 40, that's going to give you $45. So now we figured it up a little bit differently. So it's, really just that easy. You can go 9/8 and then times 40, and you get 45. So you would have gained $45. Now, another way you could have broke this down was you could have said, you bet $40, then that would be like making 5 $8 bets. And so for each one of those, you would have gained $1, which would be $5. And then you could add the $5 you made off your bet and add the money that you bet, which was $40, and 40 plus 5 is 45. Either way. Something about, okay. All right. Are there any other questions you can think of? On any homework?
Maybe just a brief overview of statistics again.
Okay.
Like that was something that I just had trouble with.
Gotcha. All right, so let's do this. So kind of kicking back to here. So the statistics started up on chapter 5 and 6. And so if I go to, I'm going to 5A, number 16. Okay. So sampling. So whenever, I'm doing a statistical study, generally speaking, the population, if I'm trying to figure out some item of interest that I want to study, such as how many people watch a particular TV show in the United States, it's not even really feasible, realistic that you're going to be able to talk to 300 million people and get their, gauge their interest. So what I do is I take a sample of the population that is representative. So however I do it, it's got to be representative of the population. And then ask the questions to that sample, and then use the data that I glean from that to make a um, draw some conclusions about how the population feels. So if the sample was bad, then it's not, your statistics are not relevant. So that's the whole, however you do the sampling, it's got to be representative of the population. So we looked at some various types of sampling, and this is what number 16 on 5A is getting at. So here are the types of sampling that we talked about. Simple random sampling, stratified sampling, convenience sampling, and last one, systematic type sampling. So now breaking those down a little bit more than that, definition wise. Right. So simple random sampling, that first one I mentioned. That's just, we choose items out of the population in such a way that the sample size has every item in that sample has an equal chance of being selected. Now, stratified sampling, what we're looking here is we're working with different subgroups of the population. So whatever those subgroups are, you draw a simple random sampling from each particular subgroup. So if, like, say your population was a high school grades 9 through 12, you may take a simple random sampling from 9th graders, from 10th graders, from 11th graders, from 12th graders. And that would be an example of stratified sampling. Convenient sampling, you choose a sample that's convenient to select. So it could be folks within the same classroom. And systematic sampling, you may have a group of, say, 500 people, and you just have those 500 people listed out, random, 1 through 500. And then you go through and pick every 5th person or every 10th person. And that would be an example of systematic sampling. All right, so question on number 16. We're going to look at IRS auditor randomly selects for audits 50 taxpayers in each filing status category: single, head of household, married jointly, and married filed separately. So so there are these subgroups? Subgroup of, out of all taxpayers, there's a subgroup of, one's filing singly. There is a subgroup of who the head of the household, married filing jointly, and then married file separately. And out of each subgroup, they're picking 50. So would that be an example of simple random, of convenience, of stratified, or of systematic? Now, I kind of gave it away when I used the term subgroup. Which one of those was subgroups? So it's kind of in the name of it. So it's stratified. So stratified is where you have subgroups within that population. Out of each subgroup, you take a simple random sampling. And so when it starts throwing these categories of different tax filers and says that they picked 50 out of each, think of them like, or, layers of rock, which are called strata. So, but so when you see there are within a population, there are these different selected groups, and then you're told out of each group, we're making a simple random sample, then you know it's stratified. Let me see if I can come up with another one. Okay, so here's number 17, which is actually asking same kind of question. All right, a computer randomly selects 900 names from a list of all registered voters. All right, and those selected are surveyed to predict who will win the next election for mayor. So would this be convenient, simple random sampling, stratified sampling, systematic sampling? So you can kind of use a process of elimination here. Since it was just 900 names and randomly selected out of an entire list, but it wasn't systematic because it didn't go and say, I picked every 10th voter in the roll. I just randomly selected 900 names off the list. So I can eliminate systematic. It's not stratified. I'm not looking at picking a simple random sampling from different subgroups. It's not convenience sampling where I may, just pick out of, well, it's just not convenience. Convenience again is where, I'll find a good example of convenience here. Here's a good example of convenience. Anthropologists determined the average brain size of early Neanderthals in Europe by studying skulls found at 3 different sites in Europe. Now, they don't have a lot of choice in that because there's very few Neanderthal skulls left to find, but they did live in Europe. So it's convenient. They just go there and that's where, the skulls are to study, just again, purely for convenience. This one, if I just have a computer that randomly selects 900 names from all the registered voters, that's simple random sampling, as long as it was random in terms of how I picked them. Again, you can eliminate systematic because that is, I pick every 10th voter on the roll or something like that. And stratified, you're looking again for those subgroups. All right, let's go to 5C. Number 12. Okay, so all I want to do here is determine whether a following variable is qualitative or quantitative. Home prices in a small town. Is this going to be qualitative or quantitative? So quantitative, just think of it basically what? Numbers. This is home prices, that's a number. So that is specifically, is it a numerical category? And yeah, home prices are. So the variable is quantitative in that example because it's a numerical category. Now, what would be an example of qualitative? The flavors of ice cream sold at a delicatessen. These are flavors. Again, that's not a, it's butter pecan, chocolate, vanilla, Rocky Road. That's not numerical. So it's a non-numerical category. Make sense? Mm-hmm. Okay. So let's go look at 6A. Number 19. So again, what I'm doing is I'm going down through the problems that are on the final, the one problems I said to go look at. Okay. Now, this one I'm going to try to go over here. 19. All right, so here's the problem on 19. This is on 6A. Suppose you study family income in a random sample of 400 families. And you're looking at what the family income is of the 400 randomly sampled, randomly picked families. All right, so the results can be summarized that the mean income of the families is 40. So of the 400 families, the mean income, that is the arithmetic average of their income, is 47,000. That's the mean. The median income. So if we arranged all the incomes from least to greatest, the middle income in that order is just 31,000. Right, so there is a discrepancy between the mean and the median here. And that your highest and lowest income, so your max income was $258,000. And your minimum income in the 400 families was just 2,200. So the first thing it asks you to do is you are given graphs to choose from, and it's a line graph, and they want to see what the income distribution would look like given this information here. So you're given 4 choices. Now the graphs themselves look like this. Frequency is on your vertical. That's how many people would have a certain level of income. And you've got every one of them starting out here at 2,200. And of course, these are incomes here on the horizontal. And up here was 258,000. So that was your total range of salaries of the 400 folks. Okay. All right. Now, and the biggest thing to remember when you are know the mean and you know the median. If your distribution is symmetric, that is normal, you get that bell-shaped normal curve, your mean and your median are going to be the same right there in the middle. But if it's skewed one way or the other, but if it is left skewed, now remember, left skewed looks like that. So you don't have many on the low end, you got them all up on the high end. Then in that case, your median is bigger than your mean. But if you're right skewed, your mean is bigger than your median. So that is, now, when you are looking at your 4 choices, the first choice was just a flat line, just came across like this. And that means that as far as there's a distribution, you have the same number of people basically making all these salaries. And that's not the case there for sure. Then you're given a graph that is left skewed, you're given a graph that is right skewed, and you're given one that is normal. And so what you're going to pick up on, it's got to be the right skewed one. That is, it's got to be one that looks like this. So it goes up and then comes down like, so most of your data is here. And again, what that's going to create is your mean is going to be more than your median. Right? And that is certainly the case here. And the reason is that one ginormous value there is going to be pulling this arithmetically up, right? Where median is not susceptible to those kind of outliers. All right, so you want the right skewed one, and then you'll pick right skewed one. All right. Now, then the next question on this problem, number 19, says how many families in the sample earned less than 31,000? Now remember, there were 400 families total. So remember, 31,000 is your median value, and it is numerically dead center in the middle. So that means there's got to be what, 200 families that make less, 200 families that make more. So you'll pick 200 simply because median is the number right in the middle of the data set. And says now the last question deals with the mean, which was 47,000. It says based on the given data set, can you determine how many families earned more than $47,000? Why or why not? You're going to answer no. Just knowing the mean doesn't tell me how many were above that or how many were below that, like median does. Median, I knew it was right there in the middle, so I know that it had to be 200 families less than that median value. So you're just going to say no, and they basically give you two choices there, no or yes, and you're just going to say no because the number of families that earn more than 47,000 depends upon the distribution. And I don't know, I'd have to have all the data in order to actually answer how many were making more than 47,000. So that is number 19. So, and then 6B, number 13. Let's go there. Okay. Okay. Now, flip the page. Six B. All right. Here you've got a lot of multiple choice type questions. This was the one that dealt with drawing out graphs and constructing a box plot. So you are given 4 different data sets, each having 7 numbers and all having a mean of 9. So it kind of looks like this. You're given a data set, 7 numbers, and they're all 9. So literally every number is a 9. And then you're given another one that is 8, 8, 9, 9, 9, 10, 10. You're given one that is 6, 6, 6, 9, 12, 12, and 12. And then you're given the last one is 4, 4, 4, 9, 14, 14, and 14. Okay, so if you go in and actually compute the mean for all 4 of those, the mean is going to be the same every time. It is going to be 9. Okay, so on the first one, you're gonna say construct a histogram for all four. And but that you're just gonna pick out, you're given 4 choices for each one. And you go through and pick out the histogram that would match up with each data set. Now remember, a histogram bars are connected, where bar graph is not. But in this case, it's fairly quick on this because here on this data set, you're just looking for the bar right at 9 because every data value is 9, and it will go up to right there, top out at 7. And so that's just a quick rough draft. Now, this one, notice it's got 2 8s, 3 9s, 2 10s. So you are looking at 8, 9, 10, but you're looking at a hit. And again, 1 occurs twice, 9 occurs 3 times, and 10 occurs twice. So 8 is only going to go to there. 9 is going to slip up to there. And then 10 looks like that. And so you read down here, find 8, 9, 10, and make sure these top out just like that. This one, the bars are going to be separated because you have 3 6s, you've got 1 9, and then 3 12s. And then the last one, they're going to be separated as well. All right. Now B, it says give the 5. So this was part A, picking out the histograms to go with each data set. B says give the 5 number summary, and then draw a blocks plot for each data set. So you're going to have to go through all 4 data sets and do this. And remember what a 5 number summary is. It's your low value, your what we call the lower quartile or quartile 1, the median, the upper quartile, and your high value or the maximum value. Now, for this first one, they're all 9 because 9's all you got. Now, for this one, your median is 9. You've got 1, 2, 3, 4, 5, 6, 7. Odd number of data, go right to the middle. It's 9. So the median here is 9. But your low value is 8. Your high value is what? 10. Now the low quartile, is simply the median of the lower half of the data. So when you cut it in half, say right here, then that low quartile is the median of the lower half of the data. So these 3 values, it's going to be what? 8. And for the upper, it's going to be 10. The upper quartile. We good there? And let's do this one. So low value is 6. Your median looks to be 9. But your low quartile is also 6. Your upper quartile is 12, and your maximum value is 12. And then on this one, again, median is 9. Your low value is 4. Your lower quartile is 4. Your upper quartile is 14. And your maximum value is 14. So when you go do the box plot, you are, now remember a box plot, we'll do something like this. Let's construct a box, kind of always this is just a generic box plot. And this would be your low value, this right here, and you would have a axis here, numbers going this way. And this is your low value, this is quartile 1, this is your median, quartile 3 or the upper quartile, and your maximum value. Note here on these last two, and even on this one, that the low value is the lower quartile and the upper value is the upper quartile. So in actuality, on the last four or last three, the number one, you've got 9. So you're literally just looking for the one that has one single line like that. And then all the others are just, you're going to get that box, because you're not going to get this coming out here and this coming out here like it kind of normally looks, since the quartile, lower quartile, was the smaller value. All right, now the last 3 questions, or last part of this, deals with standard deviation. And you have to calculate the standard deviation for the 4 data sets. Here, 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 and here. All right, so we're now reviewing over standard deviation. So how do we compute standard deviation? All right, so what I'm going to do is erase. Now I'll tell you, the first one is real easy. So remember what standard deviation is. It's kind of an average of how much the data is deviating from the mean. And you were told at the beginning the mean was 0. And since all these values are 9, there is no deviations. So the standard deviation is 0. It's like, boom, just plug in 0. Now, for this one, there is going to be a deviation. And what you actually have to do is, for each one of them, if you do this by hand, now if you have a TI-84, you can get the TI-84 to actually calculate this for you by putting in the data. But without it, you have to go through and find the deviations from the mean for every data value, and there's 7 of them. And what that is the data value, and I'm going to use X bar to represent mean. Like that. All right, so let's just calculate this one. So you would go 8 minus 9. Remember, the mean is 9. 8 minus 9. Then 9 minus 9, and 9 minus 9, and 9 minus 9. And now I'm out of room. And then what? 10 minus 9. And 10 minus 9. So you get -1, -1, 0, 0, 0, 1, and 1. Then you have to square each one of them. So that's what this represents. So square that, you get 1. Square that, you get 1. Square these, you get 0. And square these, you get 1. Then you want to add them up. So they add up to be what? 4. Then the standard deviation is going to be the square root of the sum of this, the sum of all the deviations squared, which for us was what? 4, divided by 1 less the data set, which was 7. So you're gonna divide by 6. So that's basically giving me the square root of 2/3. So I just take my calculator. I'm gonna punch in square root of square root on here. There it is. Yeah. Square root of 2 divided by 3. All right. It asks you to round this to the nearest tenth. That's going to come out, the square root of 2/3 is 0.816496, blah, blah, blah. So to 1 decimal place, you're just punching in 0.8. All right. Any questions on finding standard deviation?
Yeah, where'd you get the 6 at, Mr. Cunningham?
Okay, so so you're okay, found all the
Yeah, yeah,
deviations from mean, then I squared each one of them and I added it
Okay.
up.
right.
And so that's this right here.
Okay,
The bottom is just the number of data values minus 1. There were 7 data values.
oh, okay, I see
So,
that now.
yep, this number right here is, or what we call n minus 1. So a formula, writing it out for standard deviation in general, is the square root, and we use this what's called sigma. It just means add up all the deviations from the mean and divide it by 1 less the number of data values, or n minus 1. N is simply the number of data values. So, but that's where the 6 came from. It's
Oh, okay,
7 minus 1 is 6. So, and then I just reduced the 4/6 to 2/3, and then I put it in my calculator, square root of 2 divided by 3. My 0.8. So, but you got to do that for the other 2 data sets. And then, it asks some questions about standard deviation. It says the standard deviation is a measure of how widely data values are spread around and you're going to get big choices of mean or median. You're going to say mean. And note that the first data set between the highest and lowest value is 0. So it has a standard deviation of 0. And that the difference between the highest and low value is higher than other data sets, the standard deviation is the highest. So just a couple quick observations. So, but that one problem was kind of hitting both median and mean, and also looking at the 5-number summary, which involves median, and then standard deviation, which involves mean. So it kind of encompasses a lot, which is why it's in here. All right. Any other questions? That one?
no, not on this problem.
Okay. Well, that is it in terms of the statistics kind of problems you'll be looking at on the final. So I think I went through 6B. I want to flip back here real quick just to be sure. Yep. And then as far as probability, that's section 7A. I'm going to grab 2 problems. So it's going to be 18 problems on the final. Any other questions?
Do you care if we do like a problem from like 3C?
You have one in mind?
I don't think so.
All right.
Just to
Well,
like type a review.
okay. So we're dealing with significant digits here. So I'm pulling up a question at the beginning of this. talks about what are significant digits. And significant digits, so definition wise, are digits in a number that represent actual measurements, right, and therefore have meaning. And then so the next question it asks is, how can you tell if zeros are significant? And the answer there is the position of zeros in a number with respect to the position of the non-zero numbers is what determines the significance of zeros. So I'll follow up on that a little bit more. Non-zero digits on, so determining significance of digits. Non-zero digits are always significant, always. Okay. Zeros that follow a non-zero digit and lie to the right of the decimal point are always significant. So if you have 4.20 or 3.00, those zeros, so lying to the right of the decimal point. Zeros between non-zero digits. So like the number 4002, the zeros are significant. All right. Now, zeros to the left of the first non-zero digit, such as 0.006, never significant. These are not significant. And zeros to the right, but before the decimal point. So such as 40,000. Now, they could be, we're going to generally just assume they're not significant unless there's some reason that they stated that they should be. Now, here's another kind of way I can determine, like these zeros are not significant and these zeros are not significant by putting each of these in scientific notation. Now remember, scientific notation, put the decimal point behind the first non-zero digit, which would be 6. So in this case, how many times did I have to move the decimal place? 3 times. 1, 2, 3. And here you say this would be 6 times 10 to the negative third, because that was a number less than 1. But notice when I put it in scientific notation, there's no zeros here. And here it would be 4 times 10, and I had to move it 1, 2, 3, 4, 5. So it's 4 times 10 to the 5th. And again, when I write in scientific notation, there's no zeros. But if I had like say 402, when I put that in scientific notation, it'd be 4.02 times 10 to the second. Notice the 0 is there in that number and significant. So just throwing another, just going kind of scrolling through, looking at some other problems in 3C, gives you 1.226 times 10 to the 4th seconds. Now, first question is, how many significant digits does this number have? And if it's in scientific notation, again, you can concentrate right here. So remember, all non-zero digits are significant. So there should be 4 of those guys. And now precision, it asks about what is the implied precision. And that Could be. Do. Shoot. Okay. Um. One second. Okay. So that would be. All right, so the precision is a little trickier. So what it is, put this number in your ordinary notation, which means you're going to move it 4 places here and get this. Then your implied precision, right? So your decimal points right here, is the lowest place in the number that contains a significant digit. So 0, remember, to the left of the decimal point is not significant. That puts you at tens place. And so the number is precise to nearest 10 seconds in terms of finding precision. Is there any other problems in there you could think of?
I think I'm okay.
Okay.
Yeah,
All right.
I think that really helped.
Okay. Any other questions?
Not that I know of.
All right, good. All right, so what I'm going to do, I want to get the final, just kind of go through it, put those 2 extra problems in there and assign it. Again, I will put 12, 11, 21, 8 a.m. is the deadline for that, but all work is due at that time. And I'm going to do that tonight, just so it is done and I don't forget. And if there are any problems that come up, shoot me an email. And if you need any help with anything, I'll make time either via Zoom or on campus. So, so if there are no other questions, we'll go ahead and we'll call it a night.
All right, thank you so much. I really appreciate that.
Yep. All right, guys.
Yeah.
Have a good night.
Thank you so much, you too.